Hello, have a nice day everyone. I am teacher Ricky from the City of Mandaluyong Science High School and I'm here to discuss to you your lesson in Mathematics 9 from your applied learning modules, quarter 1, week number 2. So please be ready with your pen and paper. Please listen attentively, pay attention, and enjoy learning. Let's start. For our today's objectives, number 1, to determine the discriminants of a quadratic equation. Number 2, to describe the relationship between the coefficients and the roots of a quadratic equation. In our past lesson, we defined quadratic equation as second-degree equation expressed in the form ax squared plus bx plus c equals 0, where a, b, c are elements of real numbers and a is not equal to 0. And this kind of equation has two roots, which can be obtained in different ways. It can be done using extracting square roots, factoring, completing the square, and quadratic formula. Now, from these four ways, quadratic formula is the one commonly used and convenient to use, because in here we only use the coefficients a, no? The coefficient of the degree term, b, the coefficient of the linear term, and c, our constant term. And it's just a matter of substituting them in the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And thus, we'll be obtaining two roots, which are x of 1 is equal to negative b plus the square root of b squared minus 4ac all over 2a, and the other one is x of 2 equals negative b minus the square root of b squared minus 4ac all over 2a. So the first one is known as the positive root, and the second one is known as the negative root. Now let's try recalling this ways by giving you an example. Example number 1. X squared minus 6x plus 9 is equal to 0. So notice that this is written in standard form. Now, this kind of equation can be solved using factoring method. Because if we're going to look at the left member of the equation, this is a perfect square trinomial. And that can be expressed as the square of the quantity x minus 3 equals 0, equivalent to x minus 3 times x minus 3 equals 0, equating them to 0. We'll be obtaining two roots which are equal. X equals 3 and x equals 3, and that can be it can also be written in the form of this one, no? The solution set. So here you obtain two equal roots by factoring method. Next, example number 2. 3x squared minus 7x minus 6 equals 0. So notice that this is already expressed in standard form. Now let's try to solve this using factoring method. So if I'm going factoring method, what are its factors? Its factors are no other than quantity 3x plus 2 times quantity x minus 3 equals 0. Applying the zero product property, equating them both to 0, so we'll be having here two roots, which are x equals negative 2/3, and the other root is x equals 3. So therefore, the solution set is negative 2/3 and 3. Now, so this is applying the factoring method. Let's try having our next example. X squared minus 4x minus 3 equals 0. This time, let's try applying the completing the square. I hope that you are already aware or have already an idea on how to solve quadratic equation using completing the square method. So we transpose -3 to the right. Take note that a here is already equal to 1. After that, we have to make x squared minus 4x a perfect square trinomial. How? Just get half of -4 and square it. You get 4. And this 4 should also be added to 3 at the right side. So we obtain now the square of quantity x minus 2 equals 7. Take note that we are solving for x here. So all we have to do to get rid of the second power here is to extract the square roots of both sides of the equation. And thus we obtained two roots which are irrational because they are because part of the answer is an irrational number. So we have x equals 2 plus the square root of 7, and the other root is x is equal to 2 minus the square root of 7. So they are conjugate and irrational numbers. For our last example, we have x squared minus 2x plus 5 equals 0. So again, notice it is expressed in standard form. So at this time, let's try to use the very common way using the quadratic formula. So of course, the formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So since we're using this formula, of course, we need to get the numerical coefficients of the quadratic term, the linear term, and of course, using also the constant term. So we have a equals 1, b equals -2, and c is equal to 5. After that, just simply plug in the values of a, b, and c in the formula. So it goes like this. And of course, simplifying it further, you observe the sequence, the series of my solution here. So we will be ending up now with the roots. X is equal to 1 plus 2i, and the other root is x is equal to 1 minus 2i. So what is I here? I here actually is an imaginary unit. That's it. And we all know that the value of I is equal to square root of -1. So the reason why we have I here, because -1 here inside the radical is -1. And so we have I. So the answer here, or the roots here, are non-real because of the presence of the imaginary unit which is equal to 1. Now, at this point, we have a question. How do you determine the nature of roots of a quadratic equation without getting the actual roots? So the answer there is by using the discriminant. What is discriminant all about? The discriminant is used to determine the type of solutions or nature of roots of a quadratic equation, meaning without getting the actual roots or by just investigation using this formula, we can right away give the description or the nature of roots of the given quadratic equation. And the formula here is from this quadratic formula. So I mean, that is the expression b squared minus 4ac. That's what we call our discriminant. Now this is a radicand. In the radicand it is an expression inside the radical sign. Now, okay, we have four ways in to be considered in expressing or describing the nature of roots of a quadratic equation. The first one is when b squared minus 4ac equals 0, then the roots are real, rational, and equal. So this is that particular um, way wherein notice that you will be getting roots which are equal. No? This is the one that you will be having um, a perfect square trinomial. I mean, the quadratic equation wherein the left side of the equation is a perfect square trinomial. Next, when b squared minus 4ac is greater than 0, positive, and of course, a perfect square number or value. So the roots are real, rational, and unequal. So I'll give you a clue. In this particular way, no, you can apply here factoring. We can apply factoring here in this case. Now, next, when b squared minus 4ac is greater than 0, so it's positive also, but not perfect square. Unlike with the first one, it's a perfect square, but this time not perfect square. So what about that? Here, the roots are real, irrational, and unequal. So this is that way or that type wherein we will be getting two roots which are irrational. That is, the roots are with the presence of the radical sign. And of course, when b squared minus 4ac is less than 0, meaning negative, then the equation has no real roots. This is where we will be getting imaginary roots or the non-real roots. Yeah, so let's apply this four ways or the conditions in this equation. So what is the nature of my roots? X squared minus 6x plus 9 equals 0. So from the discriminant formula, no, b squared minus 4ac is just a matter of using the numerical coefficients, which is a equals 1, b equals negative 6, and c is equal to 9. So it goes like this. Negative 6 squared minus 4 times 1 times 9. So we have a value of b squared minus 4ac equals 0. No? So since our discriminant is equal to 0, using the first case or the first condition for discriminant, the roots are real, rational, and equal. Now let's take a look at the solution of this one in our previous discussion. So if you can still remember, the roots of this are x equals 3 and x equals 3. So notice they are real, they are rational, and they are equal because our discriminant value is equal to 0. So remember, if the discriminant value equals 0, the left side of the equation or the expression is a perfect square trinomial when it's written in standard form. No? So don't forget that. Next, example number 2. 3x squared minus 7x minus 6 equals 0. So what is the nature of my roots? No? So again, using the coefficients a, which is 3, b equals negative 7, and c equals 6. So using the discriminant formula, b squared minus 4ac, so equals negative 7 squared minus 4 times 3 times negative 6. And so the value of our discriminant is equal to 121. 121, as we all know, is a perfect square number and positive. So the roots are real, rational, and not equal. So let's look at the solution before, the one that we have solved a while ago. So see, it can be factored. Remember, it can be factored. Why? because the value of the discriminant is a perfect square. So the next time around, no, sometimes you are doubt, you are confused, you're asking yourself, is it factorable? Or this time, remember that whenever the value of your discriminant is a positive and perfect square number, oh, you have an idea that it can be factored. It can be solved using factoring. So look at this one. No? So see, so the roots are uh, real, rational, not equal. So makes sense. Negative 2/3 and 3 are real, rational, and of course not equal. Next example. X squared minus 4x minus 3 equals 0. No? So without getting the actual roots, what will be its nature of roots? So let's again use the discriminant using the values of a, b, and c. So a equals 1, b equals negative 4, and c equals negative 3. So once again, using it or substituting them in this formula, the discriminant formula, and so the value of the discriminant is 28. Or 28. 28 is positive, but not perfect square. So meaning the roots of this equation, x squared minus 4x minus 3 equals 0, are real, irrational, not equal. So irrational meaning it contains a radical, no? A radical part in the answer. Let's take a look. See? So this was again the example that we have solved a while ago. So look at this, no? So it makes sense again that the roots are real, irrational because of the presence of the radical here, because square root of 7 is irrational, and of course they are not equal. By the way, no, if your discriminant is positive and not perfect square, do not try factoring this. Do not try factoring them because you cannot really factor them. Unlike with the first case and unlike with the first case and second case. So you can just solve them using completing the square or quadratic formula. Next, example number 4. X squared minus 2x plus 5 equals 0. What is the nature of my roots? So, syempre, let's use the discriminant formula again. So a equals 1, b equals negative 2, and c equals 5. From the formula, substitute, so negative 2 squared minus 4 times 1 times 5. And so the value of the discriminant is negative 16. So negative 16, you know, falls under this description of the roots. So no real roots, imaginary, or complex conjugate. So you expect that when you solve this kind of equation, or x squared minus 2x plus 5 equals 0, expect that your roots has an I in there, no? The imaginary unit. And of course, this cannot be solved using factoring also, because the value of the discriminant is negative 16. And so let's look at the solution that we had a while ago. See, so the roots are x is equal to 1 plus 2i, and x is equal to 1 minus 2i. So again, makes sense. Again, the reason why we have here an imaginary unit or an answer expressed in terms of I, because of the fact that the value of our discriminant is a negative number. Let's continue. It's your turn. What is the nature of roots of the quadratic equation 2x squared minus 6x is equal to negative 3? Please try. Okay. Okay, take a look at this. This equation is not in standard form yet. So all you have to do in this case is to express this in standard form. Ax squared minus bx equal plus c equals 0. So let's do it first. That's the first thing that you have to do, no? Express that in a form of, or what you call the standard form. So since we're looking for the nature of roots, once again we have to apply the discriminant formula. And so using a equals 2, b equals -6, and c equals 3. So you have here, no, -6 squared minus 4 times 2 times 3. So the value of the discriminant is 12. So what is 12 here? 12 is positive, but 12 is not a perfect square number. So therefore, guess what? The roots are real, irrational, and not equal. So if you're going to solve this one, you cannot employ here factoring, because you cannot really factor this, no? So all you have to do is just simply using either the quadratic formula or the completing the square, and expect that your answer has a radical in it. Okay? Now, how do we determine the sum and product of the roots of a quadratic equation without getting its actual roots? So meaning, from the given quadratic equation, without getting its roots, we can now somehow give or determine the would be sum and product of the roots. How is it? So this time we are actually dealing with the relationships between the coefficients and the roots of a quadratic equation. I repeat, the relationships between the coefficients and the roots of a quadratic equation. Now, so if r's of 1 and r's of 2 are the roots of the quadratic equation, now all you have to do is, so by the way, I would like to remind first that your equation should be in standard form equals 0. And of course, after that, let a here, no, let the numerical coefficient of the quadratic term be equal to 1. So to make the numerical coefficient of the quadratic term equal to 1, we have to divide both sides of the equation by a, and thus x squared plus bx over a plus c over a is equal to 0. So take note, notice that the numerical coefficient now of the quadratic term is equal to 1. So what about that? Okay, this is it. Don't you know that the sum of the roots of this quadratic equation, ax squared plus bx plus c equals 0, is negative b over a, and the sum of the product of the roots is c over a. I repeat, the sum of the roots, considering that r's of 1 and r's of 2 are the roots, their sum is equal to the negative of b over a, and the product of the roots, r's of 1 times r's of 2, is equal to c over a. Let's explore more. For you to really be aware on where we arrive, or how do we arrive with that formula for sum and product of the roots, let's consider this. So from the quadratic formula, x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we all know that we have here two roots, no? X of 1 is equal to negative b plus the square root of b squared minus 4ac over 2a. And the other root is x of 2 is equal to negative b minus the square root of b squared minus 4ac over 2a. But what will I do next? I'm going to get their sum. So for me to get the sum of the roots, of course, you have to add the two roots. So notice that we can cancel here. We can cancel the radicals, no, because they are opposites. I mean, they are the same radicals, but take note they have one is positive and one is negative. So this cancels out. What was left? So we have negative b plus negative b is equal to negative 2b, and copy the common denominator, which is 2a. Simplifying this further, therefore x of 1 plus x of 2 is equal to negative b over a. So this is the one that is being illustrated a while ago. Sum of the roots. Next, for the product of the roots, so of course x of 1 times x of 2. So we're going to get the product of the two roots, no? The positive root, the negative root. So of course it goes like this. So remember a plus b times a minus b. It's just squaring the first term, no? If you can still remember, no? So negative b times negative b is equal to b squared minus this one. Their product is equal to, of course, quantity b squared minus 4ac over 4a squared, because 2a squared is 4a squared. And then removing the parentheses, so we have b squared minus b squared plus 4ac over 4a squared. So we can cancel out the b squared. So we have 4ac over 4a squared. We can cancel out 4. We can cancel out also a and a squared, leaving us a at the bottom. So c. So the product of the roots is also c over a. No? So this is the technique that we're going to use if we are just looking for the would-be product and sum of the roots without getting its actual roots. So again, it's the negative b over a. It is getting the negative, no, of the b over a. But for the product, it's just actually the quotient of the c and the a. Let's have some example. What is the sum and product of the roots, or of my roots? So since a here is equal to 1, no? So just simply, yeah, so copy b equals negative 6 and c is equal to 9 here, no? And let's use the formula. So sum is negative b over a. B, which is equal to negative 6, and a, which is equal to 1. So since negative is in here, so just get their product. So the sum of the roots of this equation equals 6. What about the product? The product is, of course, the ratio of your c and a. So it's 9 over 1 is equal to 9. So meaning to say that without getting the roots, you can now visualize, or you have now an idea. If I'm going to get the roots and getting their sum, this will be the sum, and this will be the product. Okay, again, this was the example used before, no? So look at this. Their sum, the roots are 3, and their sum is equal to 6, and the product of the roots is equal to 9. So you don't need to get their actual roots. You don't need to get use the roots, or solving this equation for you to simply get the sum. and product. No? So it goes like this. The formula, negative b over a, and for the product, c over a. I'll give you one technique here. No, I'll give you one technique. If you notice that your a here is equal to 1, no? If your a is equal to 1, all you have to do is to just negate, no? Just get the opposite of this one. Negate, no? That is if your a here is equal to 1. So what is the opposite of negative 6? It is 6. Sum of the roots. And in the case of the product of the roots, just simply get the constant term. And this is it. Let's have another example. Oh, by the way, let's check. 3 plus 3, 6. And then product is equal to 9. See? So, makes sense. Example number 2. What is my sum and product? I mean the roots of this one. So, of course, a equals 3, b equals negative 7, and c equals negative 6. So for us to get the sum of the roots, the formula is negative b over a, and b is equal to negative 7, and a equals 3. So negative 7 times negative equals positive 7 over 3. So meaning the sum of the roots is equal to 7 over 3. See? And the product of the roots defined by c over a equals negative 6 divided by this division, divided by 3 equals negative 2. So, yun na. Check natin. So, the solution for this equation, the solutions rather, are negative 2/3 and 3. Let's try to get their sum. Let us check. What is the sum of negative 2/3 and 3? See? 7 over 3. Same as this. What about the product? Product is negative 2. Now again, I'll give you a clue. Without using this one, now for you to arrive with the sum and product of the roots that fast, all you have to do is to divide all terms by 3. So divide by 3, divide by 3, divide by 3, and divide by 3. So if you divide negative 7 by 3, you have negative 7 over 3. And then getting its opposite, you have this one. And of course, negative 6 divided by 3 equals 2. And there you have your product of the roots. It's a lot easier comparing with this one. No? So take my my tip. Next, example number 3. What is the sum and product of the roots? So x squared minus 4x minus 3 equals 0. Without applying the one that we're using a while ago, no? the shortcut method. So here, since a is equal to 1, so it's just a matter of just getting this one, its opposite. The negative or the opposite of negative 4 is equal to 4. And that is your sum. And this one here, negative 3, will serve as its product. Let's go with the process. Let's try. So a equals 1, b equals negative 4, and c equals negative 3. Okay, sum is negative b over a. Let us plug in negative 4 in b, and then for a equals 1. So this is equal to 4. See? So the negative or the opposite of negative 4 is equal to 4. That is the sum of the roots. For the product, of course, it's just negative 3. No? Actually, you don't need to take this process. No? So just take this one here, no? the constant term, and you have your product of the roots. Let us check the solution. Okay, this one here, they are the one that we have a while ago. No, they are the irrational roots. Let's try to get their sum. If we're going to get their sum, we have to expect that it should be 4. So let's try. If we're going to get the sum, so of course we're going to cancel out the radicals. So 2 plus 2 is equal to 4. That's it. So the sum of the roots of this one is equal to 4. What about the product? Okay, you are multiplying conjugates, no? That's the sum and difference of two binomials. So their product is equivalent to negative 3. And negative 3 is their product. And so it's also the same as this one here, product. So once again, you don't need to get the actual roots of a given quadratic equation if you are just after the would-be sum and product of the roots. So that's the technique. For our last example, what is the sum and product of my roots? So here, notice that since a here is equal to 1, so we can automatically say that the product of the roots, if I want the product, it is 5. And the sum of the roots is negative 2. I repeat, the sum is of the sum of the root is positive 2 rather, because we have to get the opposite of negative 2. Again, sum of the roots is 2, and the product of the roots is 5. Let's check. So a is equal to 1, b equals negative 2, c equals 5 from the formula. So sum is negative of b over a. So negative of negative 2 divided by 1. So of course the sum is equal to 2, which is the opposite of the negative 2 here. No? So that's the sum of the roots. What about the product? Of course, it's equal to 5. C over a, the long process, so it's equal to 5. Now, let's take a look at the solution. Can you still remember this one? Okay, so the roots are imaginary roots, no? X is equal to 1 plus 2i, and x is equal to 1 minus 2i. So let's try to get their sum. Shall we be ending with the sum of 2? Let us check. So here, let's cancel out. We can cancel out the positive 2i and the negative 2i because they are opposites. So see, the sum is 2. Okay? And of course, the product, as expected, should be equal to 5. Let's find it out. If we're going to get their product, so we have 1 squared minus 2i squared. So it's just sound like, with in algebra, we have the a squared minus b squared. If the factors are a plus b and a minus b. So 1 minus 4i squared, take note, I squared here is equal to negative 1. No? So negative 1, the value of I squared times negative 4 is equal to 4, and then 4 plus 1 is equal to 5. So see? So that's the advantage of having a knowledge of this one, no? Because beforehand, without getting the actual roots, we have now an idea the would-be sum and product of the roots of the given quadratic equation. Now, so yun nga, I squared is equal to negative 1. Okay, it's your turn. What quadratic equation with the integral coefficients whose roots are negative 9 and 12? I repeat, write that quadratic equation with the roots which is negative 9 and 12. So what will you do? Okay. For us to know that quadratic equation with these roots, all we have to do is to get their sum and product. No? So we have to get the sum of the roots because they are the given roots here, negative 9 and 12. So get their sum, negative 9 plus 12 equals 3. and the product is negative 9 times 12 is equal to negative 108. So from this sum and product of the roots, we can now more or less write that equation. I mean, that quadratic equation with these roots. How? So just x squared, this one. Since you have the sum in here, before you place it in here in that quadratic equation, you have to get its reciprocal. You have to negate that. So positive 3, its opposite is negative 3, and that's the x. But when it comes to the product of the roots, it's just a matter of just bring it there, just copy. So the answer now, so we can now conclude that x squared minus 3x minus 108 is equal to 0 is the quadratic equation with the given roots. So for you to check, since they are now given, it's factorable. And the factors are x plus 9 times x minus 12. And equating that to 0, we'll be getting these roots. Okay, let's continue. Can I find a quadratic equation if the sum and product of the roots are given? So this is just the opposite of the one explained a while ago, because this time we are to find that quadratic equation given the sum and product of the roots. Let's try. Find the quadratic equation whose sum and product of the roots are given. So the sum is negative 8, product is negative 7. Simple as that. So our pattern is x squared. Since it's negative 8 here, it's the sum. Negative, we have a negative outside because whatever your sum of the roots, you have to negate that. So negative times negative is equal to positive. For the product, just simply copy. Equals 0. So the answer now is x squared and then plus 8x minus 7 equals 0. So see? So that's it. So given the sum of the root equals negative 8 and the product of the roots negative 7, it is defined by the equation x squared plus 8x minus 7 using this pattern. But don't forget to equate that to 0 because it's in here. Okay, let's try another one. Find the quadratic equation with integral, meaning the coefficient should be integers. So no fractional coefficients whose sum and product of the roots are given. So the sum is 4/5, a fraction. Product is negative 2/3. So we have x squared. You negate this one, get its opposite. Get the opposite of 4/5. So we have now this one. So the reason why I placed negative here, para ano siya ma-opposite. And then for the product, just plus negative is still negative. So the answer now is equal to x squared minus 4/5 x minus 2/3 equals 0. But from the given direction, the coefficient should be integers. So integers, so no fractional coefficient. So all you have to do is to multiply all of them by 15. 15 here is the LCM of 5 and 3. So 15. So 15 multiplied by all the terms inside. So the answer now is 15x squared minus 12x minus 10 equals 0. So this is now that the desired quadratic equation with integral coefficients with or whose sum of the roots is 4/5 and the product of the roots which is negative 2/3. Okay, it's your turn. We have now the answer. Okay, so if the product of the roots are negative 12 and negative 15, okay, we have the equation which is x squared plus 12x minus 15 equal to 0. And sorry, the answer is already here. Okay. Uh, I think it's not a problem, no? Um, what is important is you know what to do. So this is the answer. And of course, before we end up, we have to remember the following, no? So remember that the nature and or characteristics of the roots of any quadratic equation in the form ax squared plus bx plus c equals 0 can be obtained by finding, by finding the value of the discriminant uh, b squared minus 4ac. It should be b squared minus 4ac. No, this is the discriminant formula. So I have to remove this one, huh? Remove this one. So it should be b squared minus 4ac, the discriminant formula. Or this is the formula for us to get the value of the discriminant. And so, for the first case, when b squared minus 4ac equal to 0, the roots are real, rational, and equal. This that part or that condition where we'll be getting equal roots. That is the perfect square trinomial at the left side of the equation. Next, when b squared minus 4ac is bigger than 0 and is a perfect square, so the roots are real, rational, and equal. So here we can apply factoring. No? We can apply factoring in case 1 and case number 2. And when b squared minus 4ac is bigger than 0 and not perfect square, no, so the roots are irrational and equal. So there exists here a an answer with radical sign. And you cannot factor in here. No, you cannot factor in here. It's just using either quadratic formula or the completing the square. And of course, when b squared minus 4ac is less than 0, then the equation has no real roots. So in here, your roots, you expect that your roots are imaginary or non-real roots. And of course, the sum and product of the roots of a quadratic equation in the form ax squared plus bx plus equals 0, where a is not 0, with roots r sub 1 and r sub 2 can be obtained by, so r sub 1 plus r sub 2, sum of the roots is equal to negative b over a. And for the product of the roots, r sub 1 times r sub 2 equals c over a. Ayan. And of course, to find the quadratic equation in the form ax squared plus bx plus equals 0 with the given roots r sub 1 and r sub 2, we use the formula x squared minus quantity, the sum of the roots, x plus product of the roots, r sub 1 times r sub 2 equals 0, or x squared minus quantity, this is the sum of the roots, no, the negative b over a, x plus a over c equals 0. So that's all for today. I hope you learned something, but we have to bear in mind that skills comes from consistent and deliberate practice. That's according to Sean Allen. So that's all for today, and thank you.